Exploring Life. Chapter 22, Humans and Planet. Part 1. Human evolution didn't just shape us, it shaped the planet. Homo sapiens first appeared in Central East Africa nearly 300,000 years ago, living for millennia in small, nomadic groups. Around 50,000 years ago, we began migrating across the globe, eventually reaching every continent except Antarctica. As humans spread, the world began to change. Early hunting practices likely contributed to the extinction of large animals like mammoths and giant ground sloths. These weren't isolated events, they marked the beginning of a broader human impact on biodiversity and ecological balance. This East African savanna resembles the environment where Homo sapiens first evolved. Fossil and genetic evidence place our origins in open woodland grassland ecosystems like this one. Modern preferences for park-like landscapes may reflect deep evolutionary familiarity with these settings. But this environment also carried significant risks. Venomous snakes, spiders, and large predators, especially those active at night, and being separated from the group posed constant threats. Natural selection likely favored those who could detect danger quickly. Evolutionary psychologists suggest that common fears, such as fear of snakes, spiders, darkness, or physical separation from others, may reflect inherited survival responses. Even today, those ancient pressures continue to shape how we perceive and respond to the world around us. About 10,000 years ago, humans began one of the most transformative shifts in our history, the agricultural revolution. We moved from nomadic hunting and gathering to settled farming. For the first time, people intentionally cultivated crops and domesticated animals. This shift allowed permanent settlements to form, laying the foundation for early civilizations. But it also changed our relationship with the environment. Forests were cleared for farmland, ecosystems were reshaped, and we began practicing artificial selection, favoring traits in plants and animals that suited our needs. We weren't just living within ecosystems anymore. We had become one of the driving forces shaping them. The Industrial Revolution, beginning in the 18th century, marked a dramatic turning point in human history. Fueled by new technologies, it introduced mechanized production, steam power, and a surge in factory-based labor. But this rapid growth came at a heavy ecological cost. Forests were cleared to fuel industry and expand infrastructure. Natural habitats were destroyed, and fossil fuel use soared, driving air pollution, water contamination, and greenhouse gas emissions. It was a period of remarkable innovation for human society, but also one that intensified environmental disruption on a global scale. Today, we face new challenges driven by globalization, population growth, and our expanding footprint. Globalization itself isn't the issue, but biological uniformity is. As people and goods move, so do the organisms that follow, blurring boundaries between once isolated ecosystems. This homogenization weakens local adaptations, reduces biodiversity, and disrupts speciation. Ecologically, when everything is everywhere, nothing new evolves. Invasive species compound the problem, outcompeting natives and destabilizing ecosystems. Meanwhile, expanding infrastructure fragments habitats and disrupts migration. Growing populations demand more housing, transport, and food, straining natural resources. Rising living standards bring more habitat loss, pollution, and carbon emissions. At first glance, these cityscapes may appear to symbolize progress. But they also expose the hidden costs of globalization and modern technology. Behind the buildings and lights lie growing ecological concerns. The loss of natural habitats, the buildup of pollution, and a massive carbon footprint. These images tell a story of expansion, of human achievement, but also of mounting strain on the planet's ecosystems. Every parking lot, every smokestack, every skyline is part of a much larger equation. And wherever we go, the same hardy species follow: rats, pigeons, dandelions, bedbugs, and cockroaches, thriving in anthropogenic habitats, while countless others vanish. But there is hope. We are more than biological organisms driven by instinct. For most of our history, survival meant reshaping the environment to meet our needs, clearing forests, diverting rivers, building cities. That was our strategy. It's how we expanded, innovated, and thrived. Now we're beginning to recognize that this same impulse to reshape the world is also our greatest vulnerability. There's growing awareness of the damage we've done, and a rising global movement towards sustainability, conservation, and responsibility, gaining momentum in recent years. This shift isn't easy. It's not what we evolved to do. But we are adapting, before the consequences become irreversible, before natural selection makes the choice for us. And that change is absolutely within our reach. Now let's consider where we stand as a species. The global human population has surpassed 8 billion, and it's still growing. Projections estimate it may reach 9 to 10 billion by 2050. Much of today's growth isn't driven by more births, but by longer lives. Thanks to advances in medicine, agriculture, sanitation, and technology, mortality rates have dropped, and life expectancy has risen significantly, especially over the past century. In many countries, people gained nearly 3 months of life expectancy per year throughout much of the 20th century. Still, the replacement rate, about 2.1 births per woman, considered the threshold for population stability, is currently exceeded. Globally, we're at around 2.3, and for now, we continue to add millions of people each year. Global fertility rates may be high on average, but they vary widely across the world. Some regions are still undergoing exponential growth, others are stabilizing on the logistic curve plateau, and some are beginning to decline, bringing shifts in age structure, workforce size, and economic dependency. In developing countries like Nigeria, Niger, and Chad, fertility rates remain high, ranging from 5 to 7 births per woman. Meanwhile, in developed nations such as Japan, Germany, and Italy, birth rates average just 1.4 to 1.5, well below the replacement rate of 2.1. In the United States, the rate is slightly higher, around 1.8 births per woman, but part of it comes from immigration, not births. As global population dynamics continue to diverge, so too will the distribution of people, political power, and environmental impact. This image highlights a key pattern in modern population growth. As we've learned, most of the global increase is occurring in less developed countries, shown in blue on the graph, compared to green for developed regions. Addressing these trends may benefit from region-specific approaches. In developing countries, efforts aimed at economic development and individual empowerment, such as expanding access to education, reproductive health care, and economic opportunity, have been associated with improved well-being and naturally declining fertility rates. In developed countries, strategies like investing in parental support, promoting family-friendly policies, and adopting thoughtful migration practices could help sustain population balance and support economic resilience. As we previously learned, ecologists use life tables to understand how populations grow, decline, or stabilize. A life table is analytical. It models how long individuals live and how many offspring they produce over time. An age structure diagram is a visual representation of population composition. It shows how many individuals are in each age group at a given time. A common format used to represent human populations is the population pyramid. In this graph, age groups appear on the y-axis, while the proportion, or number, of individuals is shown on the x-axis, with males and females displayed on opposite sides. Population pyramids typically fall into one of three basic shapes: expansive, stationary, and constrictive, each reflecting a distinct pattern of population growth. This population pyramid shows the age structure of different world regions as of 2023. Notice the distinct shapes. The green pyramid, representing Africa, has a wide base and a steep taper, an expansive shape that reflects high birth rates and shorter life expectancy. This is a region in the midst of rapid population growth. In contrast, the yellow pyramid for Latin America and the Caribbean is more stationary, birth and death rates are more balanced, and the population is relatively stable. Now look at the blue pyramids for Northern America and Europe. These are constrictive, with narrow bases and wider tops, indicating aging populations and birth rates that have dropped below replacement levels. Together, these shapes tell a global story of uneven growth, demographic transitions, and the different futures facing different parts of the world. The demographic transition stages help explain how populations change over time, especially with economic development. Stage 1 reflects the pre-industrial era. High birth and death rates keep population growth slow and unstable. In Stage 2, death rates decline due to better medicine, sanitation, and food access, while birth rates stay high, leading to rapid growth. Countries like Yemen and Afghanistan are in or near this stage. Stage 3 brings falling birth rates as industrialization spreads, education expands, especially for women, and family sizes shrink. Growth slows. In Stage 4, both birth and death rates are low, and population stabilizes, or even declines. Many developed countries, especially in Europe, are here now. Some demographers add a Stage 5, marked by ongoing decline and aging populations, raising big questions about the future. As we've emphasized throughout the course, humans don't just follow biological patterns, we're deeply shaped by social and cultural values. One striking example is the wealth-fertility paradox, which can be inferred from previous slides. As wealth increases, fertility tends to decrease. Wealthier individuals and nations often have fewer children. This isn't because the biological drive has disappeared, but because priorities shift. Modern values often emphasize personal achievement, career development, and quality of life. In this context, raising children becomes a choice, not just a societal expectation. In many parts of the world, reproductive decisions now reflect economic and social factors far more than survival pressures. As fertility rates decline, particularly among highly educated individuals, important societal shifts are taking shape. When those with the greatest access to education and innovation have fewer descendants, it can influence the cultural, intellectual, and demographic trajectory of future generations. Some researchers suggest this trend may contribute to slower progress in fields such as science, technology, the arts, and business. As more children are raised in institutional care settings, additional concerns arise, not rooted in genetics, but in how opportunity, education, and creative potential are transmitted through families, communities, and cultural environments. Recognizing these patterns can inform personal family planning decisions and deepen our understanding of human ecology, helping us make more intentional choices about the kind of future we want to build. In the second half of the lecture, we explore how human choices, particularly around consumption, technology, and land use, affect Earth's carrying capacity and overall ecological health. Recognizing these dynamics helps us understand both the limits of our planet and the responsibility we carry to shape a more resilient future.